Welcome back to my channel. Today we are going to be learning how to solve percentage or percent problems in a real world context. So we'll look at percent change for increase and percent decrease, and we're going to look at two different methods for solving. The first is setting up a proportional relationship or two equivalent ratios where we compare part out of 100 to part out of a whole. And then we're going to look at using bar models to help us find the percent out of a whole amount and then also finding the percentage of part of an amount. We'll review some vocabulary terms and get into some practice problems. So let's start with our vocab. Our first vocabulary term for today is a ratio, and if you've been following along in your workbook, we are on our second portion of understanding percents. So we talked a lot about ratios in our previous lesson and really in this whole unit. So if you would like your own copy of that workbook, go ahead and check out the link in the description, and then also you can check out the links to those videos. So a ratio is a comparison between two different amounts, and really percentages are also a comparison between two different amounts. What distinguishes a percentage from every single ratio is that a percent is a portion or amount that is part compared to the whole amount is always going to represent 100. So our second vocabulary term is a percentage, which is a portion or amount in relation to a whole, which the whole is 100. So with percentages, your denominator always would represent 100. Now, our next vocabulary term is tip or gratuity, which is something that we see in real life, and an application for percentages, which is an extra amount of money that you pay for a given service. So when you go out to dinner, you leave a tip in addition to the charge of your meal. A percent increase is how much something grows compared to the original amount, and then percent decrease is how much something shrinks compared to the original amount. So we will be touching on all of these vocabulary terms throughout our lesson today. Okay, before we get into practicing some problems, I want to go over the two methods that we're going to use. So this here is just an excerpt directly out of your workbook, Percent Problem Power, and we're going to talk about this first method here of setting up equivalent ratios and solving for our unknown value. So all percent problems can be tackled using these equivalent ratios. We have a fraction or a ratio, which is a part to whole comparison, and then we have our ratio that's represented by the percentage, which is the percent out of 100. Okay, so our whole amount will always be 100 for that fraction. And then we have part over whole. And when we read through problems, you'll recognize these key words is and of. And so we'll say 36 is 20% of whatever number. So the is and of is helping us to identify the is the part that you get, and then the of is telling you what the whole amount is in that ratio comparison. So that's going to be our first method, is using those two equivalent ratios and solving for our unknown value. Another method we can use when solving percent problems are making bar models, and this is a really great way to visualize the mathematics that's happening when we're setting up these two relationships. So we start with our bar, which is representing really the percentage. It's the whole amount, percent out of the whole amount. So the whole bar is representing essentially 100. Okay, and this problem is what is 30% of 90? So the whole bar, 100%, is going to give us 90. And I want to know what 30% of that is. So you can see that then we divide the bar up into 10 equal sections, because 10 times 10 would give us 100. And I know if the entire bar is 90 and I have 10 sections, 90 divided by 10 gives us 9. So each of those sections is going to represent 9. But I want to know what is 30% of 90. So 30% would be 3 times 10, or 3 of the bars. And so if I repeatedly add 9 plus 9 plus 9, or 3 times 9, I get my answer. 30% of the whole amount is 27. So if the entire bar is 90, 30% of that, 3 of those chunks would equal 27. So that's looking at percent with a whole. Now we're going to look at parts of a percent. So parts as a percent. So what this looks like, an example would be a problem like 120 is 60% of what number? So we don't know what the whole number 100% equals, but they're giving us part of that percentage. They're giving us the 60% we know is 120. So when I make my bar model, remember the whole bar represents 100 and I have it divided into 10 sections. I don't know the whole amount, but I do know what 6 of those sections represent. 6 times 10 gives us 60. So we know that 60% is 120. And so 120 divided by 6 helps me to know or see that each of those sections would represent 20. And if I filled in my entire bar, those 4 missing sections I know would also represent 20. So I can fill those in, and 4 times 20 we know is 80. So if we start with what we know is 120, we fill in those missing pieces is 80. 120 plus 80 gives us our answer, 200. So 60% of 200 is 120. And that's how our bar model works. So let's get into some more practice problems so you can practice using it. Okay, we are going to start here with number 1, and we're going to use the bar diagram to find the percent of a whole. So all of these problems on our page are out of the whole amount. Now, if you've never done percents with a bar diagram, that's okay. And if you're feeling a little confused as I was just going over it, that's why we have to practice, and that's why we're going to do some together. So what is 20% of 150? So remember, this 150 is the whole amount because we're doing a percent of a whole. So this whole entire bar is going to represent 150. And I want to know what 20% of that would be. So since a percentages are out of 100, okay, 2 of these bars would represent 20%. So if I have 150, I know is what the entire amount is. And I know that there's 10, they're divided into 10 even spaces because 10 times 10 gives us 100, and all percents are out of 100. I would do 150 divided by 10, and then I know that each rectangle space is 15. So I'm going to write that in, 15. 15 times 10 gives us 150. So the whole amount is 150, and I only want 20%. So I only need 2. So 15 plus 15 tells us that our answer is 30. 30 is 20% of 150. Let's do another one. We're going to do number 2. So remember, this is percentage of a whole. So find the percent, 35% of 60. So the whole entire bar is going to represent 60, okay, and I want 35% of that. And so I'm going to think of it like here's 10, 20, 30, and then half of 10 would be 35. Okay, so let's think if the whole amount is 60 and I have 10 bars, 60 divided by 10 would mean how much do I have in each bar? I would have 6. So I have 6 in each bar, and that is showing me my whole amount. 6 times 10 is 60, and the whole bar is representing percentages are out of 100. So 10, 20, 30, and then it's 35, and so 5 is half of 10, and this whole bar is 6, right? So we remember if the whole bar is 6, but I only want half of it, okay, 3 and 3 still make 6. So, and then I'm highlighting what 35% is. 35% is 6 plus 6 plus 6 plus 3. Or you can think of it as 6 times 3, which is 18, plus 3 more gives us 21. So 21 is 35% of 60. Okay, now we are going to use our equivalent ratios to solve for percent. So we're starting with this problem number 1 here. 15 is what percent? So we're solving for the percent of 75. So we're going to fill in with these diagrams here to help us. So remember that a percentage is out of 100, and this is what it's asking for. We don't know what the percent is, but we do know that it's out of 100. Okay, and then 15 is what percent of 75? So remember, fractions are part to whole comparisons. So 15 is the part of the whole amount, 75. So 15 over 75 is our next fraction. And then we want to look at, you can cross multiply, or you can kind of look for the pattern to see, am I dividing or multiplying to get from 100 to 75? So like this, I think of, I would be multiplying by 3/4 to get to 75. Okay, but we're going to cross multiply here. So I have 15 times 100 is 1,500, and then that is going to equal 75 times, we don't know what that is, so we're going to call it x. Okay, it's our unknown amount, and then we divide by 75. So 1,500 divided by 75, if you want to write it out as long division, you can. You get 20. Okay, so our answer is 20% is, so I got to add my percentage sign. The answer is 20%. Okay, 20% is 15 over 75. Let's do number 3 since it's just right here and it's different. If we look at number 1, we were solving to try to find what the percent is, but number 3 tells us our percent. It's 35. I want to find what 35% is of 60. So we're going to fill in our equivalent ratios here, or proportional relationship. So the percent is 35 out of 100. And then find 35% of 60. So we don't know what 35% is, but our whole amount is 60. Okay, so we can cross multiply here. So we have 100 times x equals 35 times 60. And you can write it out if you want real quick. 60 times 35. 5 times 0 is 0, 30, 0, 0, 6 times 3 is 18. So we get, I'm running out of space, 0, 0, 8 plus 3 is 11. Uh, 2,100, right? It equals 2,100. And then we divide by 100. So it is 21. 21 is the part out of the whole amount that represents 35% of 60. All right, there are a lot of problems in this chapter if you're working in your workbook. So percent increase, now we're going to be doing word problems. So everything on this page, all 6 problems are percent increase. So we're just going to do one. Jordan earned $400 last month. This month he earned 25% more. How much did he earn this month? So we know that increase, it means it's in addition to what he earned last month. So we got to figure out what is 25% of 400. If you want to use your bar model, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10 bars in there. The whole amount is 400, and 2.5 of them would give me 25. So 10 divided by 400 would mean that there's 40 in each, right? So each of these would be 40. And this one, I want half, so that would be 20 and 20. So with my bar model, I know that 25% is 1, 2, and half. So I would do 40 plus 40 plus 20, which gives me 100. Okay, you could also think if you took 400 and divided it up into quarters or fourths, you would have 400s, right? So that's correct. So, how much did he earn? Not percent, $100. Okay, so that would be $100. And so then how much did he earn this month? We have to add that $100 to what he earned last month because it was an increase. So he still earned the $400. He earned 25% more, so $100 more. So this month he earned $500, and that would be our answer. Right, the last problem that we're going to do today is percent decrease. Okay, so everything on this page is our percent decrease problem. So we're looking at, we have a winter jacket that was originally cost $120, but now it's marked down. So that verbiage marked down is what signals or helps us know that it's percent decrease because it's going down by 25%. So we want to know what is the new price of the jacket with the sale. So we have, since last time we did the bar diagram, let's set this up as a proportional relationship. So we have 25 out of 100. That's our percent, right? It's 25%, and all percents are basically fractions or ratios out of 100. So that's what 25% is in fraction form. And then the original amount, the whole entire amount is 120. We want to know what part of that amount we don't have to pay if it's the decrease. And so now we can cross multiply and solve for x. So we have 100 times x, and then a 25 times 120. If you want to do it on the side, you can do it by hand. 120 times 25. The answer is 3,000. Okay, I divide by 100. 3,000 divided by 100 gives us 30. Okay, so x equals 30. So it would be $30 off. Okay, so if our original amount is 120, then we're going to subtract that 25% discount, and now we can purchase the jacket for $90. So the new sales price is $90, and that would be our final answer. Okay, we covered a lot of information today solving percent problems in a real world context, and we went over 2 different methods. So it's okay if it feels a little overwhelming or like it's a lot at first. Remember that nobody gets anything on the first try. It's about putting in those reps, showing up. Consistency always wins. So if you need to, you can pause the video, take your time, redo it. You can re-watch the video, redo the problems. Practice is what's going to help you solidify that understanding. Also, you can check out these other 2 videos to help you better understand percents and ratios and what that looks like in application. Thanks again for watching, and we'll see you next time.